Hello, all my good-looking people. I'm gonna be showing you stellar energy. Yay! Education. Yay! Okay, so what you see here is this is the solar radiation, right? So pretty much all I did is just count the solar radiation in between A to B. So see right here in the red, you can see that's all the A's, then B's. I continue this down to M. And this is pretty much what I graphed. So I just graphed right here. You can see right here, this is the number of rays I got. And you can see how it's weird because how the rays towards the middle of the equator where it's hottest, that's where I see most of the rays, apparently it looked like. So that's where apparently earned most of the rays. So that's where it seems hottest. Then as it fades off, like from A or maybe J or M, any of that, starts fading off, and the numbers start decreasing, and it's pretty dramatic. And see right here in this graph, you can see that it shows all the numbers. So I just pretty much graphed it, and you see right, this is where it's highest. This is where it's highest from the middle. This is where it's highest. Then right here, this is the A, north and south pole. Imagine these are the north and south pole. This is where it starts getting colder. It starts getting chilly. And this is what I represented. Have you guys ever wondered either HR8799 or the sun emit energy? Like, are they the same or anything? Do you guys even know? Well, here's what I think. I think HR8799 emits more energy because of the intensity of the star is way higher than the sun. Because when you look right here, you can see that it's way launched up. It's launched up really high. See right here. You can look right here. See, it's way up here in the intensity. So you look at it, it's going way up here, and this is the sun right here. So you look at the key, look at it, the sun's right below, and the intensity of the HR 8799 is way up here. So that's why I think it gives off more energy. Also, have you ever asked yourself what are these high peaks right here from here in the sun and the star? Well, the star is right here is its highest because that's when it provides lots of radiation, like from an X-ray. That's why we wear a vest. But from a star this strong, I don't think we could wear a vest to protect us. But from a sun, we could probably deal with it because it gives us visible light. That's why you see what you see right now. That's why you're able to see this presentation right here. I've also asked that, since they both are, they seem right here equivalent energy, do you think they'll, give humans sunburns? Well, here's my opinion. Well, I don't think you could give each other sunburns because from the sun itself, I don't think you could get too much sunburns. You don't get that much too often as long as you wear sunscreen and stuff. But you get up here, it's the intensity is a lot higher. It gets reaches up there. So see right there in the end, it's look at this. They both kind of match up. So what I think is I don't think you get a sunburn as often as long as wear protection and everything. So I think they're both equivalent sunburn. So as long as you stay healthy and everything, you shouldn't get a sunburn. So stay not burnt. Well, to me, learn this concept of things is this right here, this little thing. So pretty much what I learned is this is right here is the sun. This is the light shining onto Earth, and this is obviously Earth. So depending on the angle of right here, the sun's gonna be lighting. So when it tilts, you can see right here it's really hot, and then this is where it fades. The sun fades away. It's a shadow. So over here it's like nighttime, and over here it's like morning time. So this is what really helps me is because as it go, it spins around and around and around and around and around. And you just see right there, you can see how the sun keeps shining on it as it tilts or spins around. And as it tilts, you can see how it gives a great example on how the sun shines on the earth. Have you ever been hearing someone ever say, "Today was sure a cold day"? As Earth orbits the sun, winter occurs when the sun is farthest from the sun. Have you ever asked, is that statement really true? Well, I think it's really true because look, I'm gonna look right here. So you see right here, this is like summer when it goes straight. So, when the sun shines directly on you, it's pretty hot. It's pretty hot. Like right here, it's kind of colder, but it's pretty hot. Then right here, you can see in the corners, like imagine this in the corners of the sun rays. Like this is the flashlights are the suns. This is the rays shining on the edge of the earth. See, look. Right here, this is another example. See, this is from the past one right here. See this? This is the cold, the winter. Look, look. Look at the comparison. Straight down, this is going straight at it. And look, this is like the edge of it right here. See right here? That's the edge. Look at this. This is the edge. You can see right here. Right here, you can see the sun kind of, hid in the corner. And this is where you don't get too much sunlight. So this is like a shadow, long shadows. It's spread out, and this is when winter occurs. Here's another example. If you just look at it, okay? Look. This is right here. This is the no shadow. There's no shadow. It's the sun's directly on it. And there's some short shadow. This is like maybe a spring or something, Then right here in the corners from right here and here, this is like winter time. This is winter time because not too much rays are on it. It's very long shadow. It's it's really long. So right here, this is when winter occurs most of the time. Most of the time, usually. Remember when I said this really would help? Yeah, look at this. It's the same thing. The sun's rays are on the earth. It's going directly at it. So this area right here would probably be really hot. Then as you go farther away from that rays, then you can see right here, this is when it starts getting winter, cold, right here and here. That's when it starts getting really cold. This brings all the way back from the beginning. You can see right here, you can see this is this sunlight, see, from A, B, C, D. So G, this is the equator. This is when you earn a lot of sunlight over here. Lots of sunlight in the middle. Then right here, as you fade away, you start getting less radiation through here. You start earning less. And see, right here, there's not too much rays. This is where the shadows fall off, and this is when usually it starts getting cold. That's why the North and South Pole are really cold places. Because, do you know why? Because of this. This is my theory. This is why when this quote is can be true, but you got to mention the tilt. The tilt really is a factor. The angle is the factor of the sun projecting its rays on the earth.